Okay, so where we left off in class is we were talking about arrays, and we can create arrays. So in general, an array is a collection of like-type objects, right? We were creating arrays of strings and arrays of ints and arrays of chars and all sorts of stuff like that, and we were filling them up. We would then pass them. So just as an example here, I've decided we're going to have 100,000 patients. So we create a new array of size max patients. We spin through here. Actually, good programming would have done that for the maximum number of patients. Each time through, we're going to call our function add patients, and we wrote it twice, it looks like, and we're passing it a string. So add patient is going to take in a string and add it to our array. So notice we're keeping track of the current number of patients we have in there because we have an array capable of holding 100,000 patients. But until we start putting patients in there, we don't have any patients. So we're keeping track of where does the next patient get added. We go in here, we add the patient at the right place. And then increment the current number of patients. As opposed to the first way we did this, which was destructive, we had add patient, where we actually took the array of patients, made it one larger than it used to be by creating a brand new array that was a little bit bigger than the previous one and copying everything over, then adding our new patient and ultimately updating the pointer. So this is kind of our example of looking at arrays as being very fast but very memory inefficient. So we can create a giant storage location for holding a bunch of stuff, but if we want to change the size of that, then we need to start messing around with creating new arrays and stuff like that. We're going to look at an alternative to this in the next class in 300, something called linked lists. All right, so any questions about arrays and going through arrays? Do they actually show an iterator in here, or do they still use for loops? Do they show a for each loop?
I don't remember if you ever.
Well, I just want to see if the book did a for each loop.
Oh.
Yeah, they did not. Okay, that's fine. So I'll show a for each loop at, well, let me just show it to you now. One thing to for us to consider here is, so we don't have class on Thursday, right? Yeah, fall break starts at 4 p.m. tomorrow. So you have classes earlier in the day tomorrow, but any evening class you have tomorrow you won't have. So the next time we will see each other is on Tuesday. On Tuesday, we will talk about the midterm. We'll have the midterm on Thursday, so a week. So 9 days from today, we'll have the midterm. It'll cover everything we've covered up to this point. As usual, my exams are 10 questions, 10 points apiece. There will be some programming on there. There will be some non-programming. I'll go through the slides on Tuesday and tell you what things I think are kind of important and what things are maybe less important. I might not make it onto the exam. Also remember that my policy is if you do better on the final exam than you do on the midterm, I'll replace the score you get on the midterm with what your score you get on the final. Not the other way around, though. So if you do poorly on the midterm, that tells you where you need to improve, and then you can come and improve on the final and fix your bad midterm score. All right, so shouldn't be a huge deal, but we will talk about that on Tuesday.
You mean next Tuesday, right?
Yeah, that would, yes. Yeah, that was, could I have meant anything else?
No, just misinterpretation.
No. The funny thing would be, it's like, no, and just let that sit. Like, you mean next Tuesday? Like, huh? Yeah, next Tuesday. We'll talk about that. All right, so let me quickly show you a for each loop. You won't use it very often, but just because we're in the
area.
yeah.
What is the 4H loop do different for?
It's kind of a quicker way of doing a for loop, but you do lose some flexibility. So let me just take, I'm just going to gut this. All right, so I'm going to go ahead and I'm going to create a string array. We'll say AR is equal to a new string array of size 10. All right, and then I'm going to go ahead and fill this up with some strings, and we'll actually do this, use this for a little bit of review. So I'll say static void fill array. This guy will take in a string array as a parameter. I'll purposely name it something other than AR just to really drive this point home. So we'll call this guy LOL. All right, and what I want to do is I want to go through every element of LOL and just fill it up with some string. So I'm going to say for int I is equal to 0, I is less than LOL dot length. Catch up. There you go. I plus plus. And then we'll say LOL at bucket I is equal to some string concatenated with I. So some string 0, some string 1, some string 2, some string 3, so on and so forth. All right, I will fill that up. I'm also going to give myself another quick function called print array. It'll take in a string array as a parameter. I'll call this guy woot. I'm purposely calling them different names just to reiterate a point that we're going to talk about here in a second. So for int I is equal to 0, I is less than woot dot length. That is the number of elements that, the maximum number of elements that woot can hold. I plus plus. And we'll go ahead and say system.out.println woot at bucket I. All right, so this function here will take a string array as a parameter and print out every element in a string array, right? Is this a class method or an instance method? Class method. How do you know? Oh, static. Class method, because it's static. How do we call class methods? We would call class methods using the name of the class and what's the method was defined. All right, so we would call this guy by saying, in this case, driver dot print array. Okay, 100% promise that concept will be on the exam more than one time. If you notice, I mentioned this in class a lot. This whole, is this a class method or an instance method? So get that straight in your head. Class methods, when you look at the definition of them, have the word static in front. Instance methods do not. When you are seeing them being used, not being defined, when you see them being used, if a method is being called with the name of the class, it's a class method. If you see it being called with an instance of a class, it must be an instance method. Make sense? Class methods are called using the name of the class in which the method was defined. Instance methods are called using an instance of the class in which the method was defined. So have all that straight. Otherwise, you'll probably have a max score of a 70 on the exam.
Out of 100?
If you miss all 3 questions dealing with that, yes, 70 out of 100, that would be your max score because you'll miss 30 points on what should be a drilled into your soul concept by now. Make sense? Very, very, very important concept. Because I promise you, none of you are going to memorize the entire Java language. Ever. Okay? I don't know the whole Java language, and I've been writing Java since it came out. I know a very small percentage of the language. That means it is a very important skill for us to be able to read the documentation and put any aspect of the language that we haven't used before into immediate use. That means knowing how to call it by recognizing is the class method or instance method, and how do I call one of those? Make sense? Way more important skill. In fact, you never want to sit down and, well, never is probably the wrong answer. Rarely do you want to sit down and memorize code. Some of the things I've had you memorize, right, is like hello world. So you always have a starting point for a program, and then kind of your stock structure for a for loop if you're going to spin through a string or an array, those things. But you're going to accidentally memorize those by just using them all the time, right? At this point, almost every program you write has a for loop in it. So just from repetition, pun intended, you're going to end up getting used to those things. But there's aspects of a language that if you don't use it forever, you might like, oh, what was that guy again? You have to go and look it up or something, and that's fine. When you're working as a software developer, they're not going to lock you in some room somewhere without any references and say start coding. Okay, you're going to have access to, well, they'll lock you in the room, but you'll have references. That's the difference. All right. So we want to work on the programming skills, not memorizing a language. Make sense? All right. Go ahead.
Can you just remind us what the LOL are?
Yeah, I'm actually going to, so give me 3 minutes and I'm going to, I purposely named them something different here so I can reiterate that point. Yep. Because typically I would have named my array here AR, I would have named this AR, and I would have named this AR. But I purposely named them something different just to reiterate this stuff. All right, so print array is going to take in some string array. The number of elements in that string array are the length of that array. And then I'll print out all the elements. Fill array is going to take in a string array. It's going to go through and fill up that string array with some stuff. So first I want to prove something here. We said that these are class methods, right? So I'll say driver.fillArray. The array I'm going to fill is called AR. All right, so I have a local array here. So this is an array that lives in the current scope of main. All right, so I have a local array. I am passing that array in to fill array. Here's fill array. Fill array requires one input. So this is starting to answer your question. So fill array requires one input. Specifically, it requires a string array. So I'm giving it a string array. Which string array? AR. It's getting passed in here, and there's a local variable in this scope called LOL, which points to the same place as AR. And just to prove that to you real quick, I'm just going to do a system.out.println AR here. And what kind of thing should this print out? Memory address. Okay, so this guy's going to print out a memory address. And similarly, if I come in here and I say system.out.println LOL, that's also going to print out a memory address. What we're going to see here is when I print out the memory address of AR, it's going to print out one memory address. Then when I call fill array, passing AR into it, I catch AR inside of a variable called LOL. Then I print LOL out. You're going to see it's the same memory address. Okay? Fill array expects a single parameter of type string array. I am providing it with that single parameter. So in this context, LOL is a synonym for AR. Why do I need that? Because AR scope lives and dies right here. So inside of this scope, I do not have access to AR directly. Instead, AR was passed in, and I stored it inside of a local variable called LOL. Typically, I would probably name it the same thing, AR, because it's an array, but I purposely didn't name it the same thing to really drive the point home that the names matching have nothing to do with it. Make sense? All right. So we'll see that the memory address of AR here will be the same as the memory address of, the value of AR, which is a memory address here, will be the same as the value of LOL, which is a memory address here, because AR is what was passed into LOL in this particular call. Go ahead and run that. Might be a little tiny text, but I promise you they're the same memory address. You got it?
No.
Oh, here, I'll put it back up. I was just screwing with it. She was taking a picture, so I immediately minimized it. This is all because I didn't get the mystery box with was it the cricket?
Okay.
I
Yeah.
give you the certificate right there.
You gave me a certificate?
Yeah.
Oh. As a monkey survivor. So she gave me a certificate. The certificate is given to Dr. Lippman as a monkey survivor. I did see one monkey.
Only one?
Only one. Apparently they're all north this time of year. They migrate to the north part of India. I was in the south part of India. But we were driving down a road and I saw a monkey sprint across the. They are fast. I mean, this thing was going a minimum of, I don't know, 800-900 miles an hour. No, it was going way faster than a person could ride. Way north. Yeah. I mean, India is a big country, so it'd be pretty similar to here. You know, yeah, I mean, the southern part of India gets a little warm. Just like our south gets hot here. Probably the hottest temperatures in India are hotter than here. Because this is during their cooler months right now, and it was 102 every day. I have a screenshot of like the Weather Channel thing. It was 102 with the current conditions said smoke. What does that mean? The sky is on fire? I didn't see any fires. Might be too hot. It's too hot for fires.
So what is their lowest temperature?
The lowest temperature this time of year is like 101. Yeah, I don't know. At night was probably in the 70s. Well, the winter months where I was in southern India is probably low 90s. Something like that. I mean, it's warm year round where I was in southern India because I mean, it's probably pretty similar to like Florida. Yeah, or not is close.
Yeah, not right.
Yeah, it's down there. you're dealing. I think if you look at it on the map, the southern part of India is kind of right around the same area as like the southern part of Mexico. In terms of like, what is that? The latitude lines, right? The cross, longitudes up and down, latitudes cross. Sounds right. You've had this stuff way more recently than I have.
Like 2 years ago.
Yeah, it wasn't 2 years ago for me. I promise you that. It was your age years ago, and plus a couple. We're up north?
Yeah.
Maybe. Yeah, that's kind of the way they indicated. But they get snow way up north. I mean, because right on the northern border between India and China is where Mount Everest is. Yeah, the Himalayas, there's snow all over them all year. So, I mean, they get the same stuff. But where I was a little warm. All right, so I passed this guy in here. LOL is a synonym for AR. We saw that those memory addresses are the same. So this was my way of exposing this variable from this scope into this scope, giving myself access to that guy, even though I couldn't directly access him through his variable name because it lived in a different scope. Does that make sense? Okay. Now, the fact that I'm seeing a memory address here, and this is something for those of you who are in the game programming class we talked about this morning, the fact that I'm seeing a memory address here tells me that arrays are passed by reference or similarly passed by address, which means when I make a change to an array, that change has side effect. It's permanent, and we're going to see that here in a second. All right, so I'm going to take out my little print statements here just so everybody's convinced that they're the same memory address. Okay, so go ahead.
So I typed it and it like underlined my eyes on the bottom of the file.
It underlined your eyes down here.
Did you declare?
Did you say anti equals here? Yeah, so you wrote something similar. You wrote something similar to what I wrote. All right, so we're all convinced that AR here is synonymous with LOL here. And this has to do with this guy expecting an input and us passing it an input right here. That's how we send things between functions. Okay? So I'll just take out those couple of print statements here. So as my program runs right now, it doesn't actually display anything, even though it does some stuff. Because right now I'm only calling fill array, which just fills that array up with a whole bunch of strings. Next, I'll call print array, which is also a class method because it has the word static in front. How do I call class methods? Using the name of the class in which the method was defined. So I'll say driver.printarray. I'll go ahead and pass it AR. So this guy is expecting me to pass it a string array. So that's really the case here. It's expecting a string array. I'm choosing to call it woot here. Me calling it woot, the only impact that has is that's how I have to refer to it down here. Okay, what print array is expecting me to give it is a string array. That's it. And what am I doing? I'm giving it a string array right here. I'll go ahead and run that. You see that we have our string array filled up with stuff, right? And this is evidence of pass by address. Because if you look at my fill array here, fill array returned nothing, right? Return type is void. So that means I passed in a string array, I changed that string array, and I did nothing else. I didn't return it. So I relied on the fact that this guy was passed in by address, and then me making changes to that had a global impact at whatever lived at that memory address. That makes sense? So this guy's passed by address. So then when I came back up here, after this call here, AR was modified because that's what fill array did. Fill array changed it. So now when I pass an AR into print array, I'm passing it the version of AR that has now been filled up from fill array. And then it printed all the elements out. All right, everybody cool with that? Okay, so I currently have a array filled up with strings. So I'm going to write a second version of print array here. And this guy will take in I'll just call it string array woot again, whatever. And I'm going to show you a for each loop version of this guy. I need to call this guy print array 2 or something other than just print array since we already have a print array. Real quick, I can actually name it print array if I want. But I'd have to have it take in either a different number and or type of parameters. Okay, I'm going to talk about that here in a second because this allows me to further emphasize this idea of parameter names. So notice here I have a method called print array. So this is still back to the idea of LOL and woot and all that stuff. So I have one version of print array that takes a string array woot. I have another version of print array. Well, I've been speaking Telugu for 2 weeks is the problem. I have to switch back now to English because I'm fluent in Telugu. So I have a second version of print array here, and this guy takes a string array LOL. Now notice that Java thinks these guys are identical. As a human being, I look at it and says, well, one of them takes a woot, the other one takes an LOL. Java doesn't care. Java doesn't care what you name your variables. From Java's perspective, I have a method named print array that takes a string array, and I have another method called print array that also takes a string array. Those are the same method, according to Java. Make sense? If I happen to have a second version of print array that maybe takes in another parameter for some reason, Java's okay with that. Now it says, oh, you have two different methods, both call print array, but I can differentiate between the two of them because one of them takes a string array, the other one takes a string array as well as an int. That makes sense? All right, and that's a concept called polymorphism. When you have a object. In fact, let's add that to our notes. Is that already in the notes?
No, we haven't talked about it.
So I love polymorphism. It's like one of my favorite words. It's the top 1,000 favorite word. Well, all the other ones are in other languages. And most of them are bad words.
I like the word.
All right, so we have this concept called polymorphism. And this isn't a Java concept. This is a object-oriented language concept. All right. Polymorphism says that there can be more than one method with the identical name, but that take a different number and or type of parameter. Note, parameter names do not matter. In our case, Java only looks at the types. Make sense? All right, so that's something called polymorphism, which is just a really fun word to say, and it's a fancy way of saying you're allowed to have more than one method with the same name, provided that they take a different number and or type of parameters. Okay? But in our little example here, I'm going to call them something different because they're going to take the same kind of parameters. So I'm writing a second version of Woot. All right, so let me show you this work first, and then I'll explain what's going on with that. So print array 2, I wrote it just a little bit different. We'll call print array 2 here. I'll run it. Save outputs. Okay, so let's explain what's going on here. So here's my two versions of print array. One of them uses our traditional for loop. The other one uses a loop that I called a for each loop. All right, so in a for each loop, we still say the word for. Now, for each loops work on arrays of objects. So I'm saying I'm going to have a variable of type string that I'm going to name S. And each time through Woot, I want S to be equal to the next string that lives in Woot. All right, so the first time through, it'll be S at bucket 0. The next time through, it'll be S at bucket 1, S at bucket 2, S at bucket 3, so on and so forth. So this guy allows me to iterate over all of the elements in an array. But I don't have access to I. So I don't have access to what position in the array I'm in. Which, if I'm just printing them out, that doesn't matter, right? If I'm just displaying the elements of the array, I don't need to know I'm at bucket 5. But sometimes you might care where you are in the array, in which case either a for each loop isn't the right tool, or you might have to augment your for each loop with a counting variable to keep track of where you are in the loop. Does that make sense? All right, so a for each loop isn't necessarily better or worse than a normal loop. It's just another than a normal for loop. It's just a tool. If you only need to spin through the elements in an array, this guy's he's good at doing it. If you need to actually have access to the indices, then you might use a traditional for loop. If you decide that a for each loop is just not for you, you can spend your entire life and not use one. You just write a traditional for loop. Your life will go on. Okay, so it's more of a convenience thing. Okay, and we did see this last semester in Python, because in Python it was pretty common for us to spin through lists of elements. we would have said, like if we had a list called woot, we would have said for S in woot, and then we could print out S. Okay, so just more trivia stuff. On an exam or something like that, I would not ask you to, I don't want to promise that. Very, very, very unlikely that I would ask you to write a for each loop. If you want to use one in a solution to a problem, that's fine. If you always want to use a normal for loop, that's fine as well. Yeah, so there's not a significant advantage other than maybe just a little bit of space saving. Is, you know, a for loop, you kind of have to remember these 3 different parts to kind of build your for loop, where this guy's maybe a little shorter or something. Yeah, but you still have to remember the special syntax of having the colon here and that stuff. So I'm not sure it helps you that much. All right, so questions about that? All right, so that's more trivia type stuff. All right, and we understand the idea of pass by reference. In fact, I'm going to actually throw that on another slide. I think we probably talked about it, but I'm just going to put a big header here. Arrays are passed by, well, let's see, let's just do it this way. Variable passing. Pass by reference. For example, arrays and objects are passed by reference and pass by value. Primitive types are passed by value, which means that when we change them, that change is not permanent. I'll go ahead and throw a little addition here, and structs. So Java does not have structs, but for those of you who are in the game programming class, we're dealing with C#, and C# does have structs. C++ has structs. C has structs. Those are all passed by value. Okay? So Java doesn't have one of these guys, but if it did, it would be passed by value, because that's how structs are passed. Okay, so this is really another connection to that idea that the language doesn't matter. You know, 90% of languages behave the same, and you just have to learn the little idiosyncrasies between the 2 languages that are seemingly similar that might have just a little bit of changes in behavior or something like that. Okay, so back in here. So we're good with this. Then the book talked about this thing called multiple arrays, which I typically refer to as parallel arrays. Well, I assume that's what they're talking about there. So 2 arrays that have the same number of elements in it, but deal with, letter rates, postage stamps, yep, postage costs. So just using this as an example, they have 2 arrays here, one called letter weights and another one called postage costs. And these 2 arrays have the exact same number of elements in them. All right, so bucket 0 of letter weights has a direct relationship with bucket 0 of postage costs. Well, if you remember back when I introduced the primitive types in Java, so we have floats and doubles. Doubles tend to be the default way that people use floating point values, whereas ints tend to be the default way that people use whole numbers, integer type values. No, yeah, it's kind of actually interesting that it's like that, because doubles do take up more space, and they do have higher precision, and it's probably that trade-off where today we care less about space and maybe precision is a little bit more important. In fact, in most of our languages, and we've seen this for those of you who are in the game programming classes, when you have a function that takes in a floating point value, you actually have to put the letter F after it. To tell you that this guy is actually a float.
We use floats way more often than we use doubles and
or in C sharp.
It's because a lot of those functions came from C. Yeah, a much older language. So let me see if I can give you an example of this. So double val, and then val is equal to, actually, sorry, I'm going to change this to a float. Float val, and then I'll say, just do it all up here, is equal to 3.14. Yeah, notice that it's not happy with that. So 3.14, it says type mismatch cannot convert a double to a float.
That is a float.
We look at from a human perspective, like, yeah, that's a double. I have to put an F after it to tell it to treat it as a float.
So if you just put it as a double.
Yeah, if I say I'm going to store this as a double here, then I don't need the F.
Why is that one?
Oh, because I haven't used it anywhere.
Oh.
Yeah, it just said you defined some variable and never used it. Did you waste your time? That makes sense? So this really has to do with more of a modern approach to programming where, at some point they had to, and this really comes back to variable resolution. If you look at the number 7, you don't know whether that's a byte or a short or an int or a long, right?
No, this is 7.
It's just a 7. Okay, you don't know if that a 7 would definitely fit in any of them, right? It would fit in a byte, a short, an int, or a long. So the default is to treat whole numbers as integers. Just as the default, if you see 3.14, that'll fit in a float or a double. The default is to treat that literal type, 3.14, as a double. So if you want to put it into something capable of holding a float, you got to put the little f at the end of it and say, treat this guy as a float. All right. This isn't something that will come up that often in, call it business programming. But when you're doing game programming or stuff dealing with a lot of mathematics, it might come up with some older libraries that you might be using. As you might imagine, like physics and stuff has not changed, right? So like the physics that they would have taught in a class 100 years ago is the same physics they teach in classes today. I mean, they might have discovered some new stuff, but they didn't like change the rules of, like how fast something will go with the constant of gravity and that kind of stuff. These are pretty much stuck. Okay? Yeah, so you might be dealing with libraries that were written in terms of we're in an era where memory size is important, so we're going to choose floats over doubles, where today we just don't care. And most languages default to a double instead of a float. Make some sense? All right. But yeah, so in any case, let me just actually show you. I'll just write a quick example. We'll do this real quick for V. We'll put it on Slack. And then we'll immediately delete it after I delete the... All right. Friends example, something like that. All right, so now I can get all this. Okay, so I usually call them, so your book called it multiple arrays. I usually reference them as parallel arrays. So this is 2 or more arrays of the same size where identical positions in each array are related to each other. Something like that. Okay. So in their example from the book here, I guess just to expedite things a little bit, they have two arrays, one called letter weights, one called postage costs. These guys have the same number of elements in it, trust me that they do. And they're saying if a letter weighs a 1.0, the postage cost is 49. If it's a 2.0, the postage cost is 70, so on and so forth. See how those guys line up? Okay, so now what we might say is multiple arrays or parallel arrays is kind of the precursor to objects. So this is something that would have existed before object-oriented programming, right? So if we just operate off as letter weights and postage costs, let me actually, I'll just steal these two arrays from them here real quick. I have a fixed indentation thing. Yeah, it's Control I. I don't know where it was in the menu system, but if you ever have stuff that's like off kilter like that, if you pasted some code in, which try not to paste code in too often, but if you did and you want to clean it up, just highlight it all. If you're on a Mac, it's Command I. If you're on a PC, it's Control I, and that will go through and re-auto indent everything. All right, so I have two different arrays here. And this is actually the way you can create a literal array. So this is generating an array and we're just hard coding the values into the array, as opposed to creating an array of a certain size and going through and filling it up with all those values. Okay, so convenient way of creating an array. All right, so now we can actually go through and we can say for int I is equal to 0, I is less than letter weights dot length, or we could have said postage cost dot length because it's the same number of elements. I plus plus, and then we would say system dot out dot println. Actually, I want to check something here real quick, so I want to show you something. Yeah. So println this letter has a weight of letter weights and bucket I concatenated with and a cost of, I'm actually just going to kick it down a line here. This is a postage cost. All right, so I'm going to spin through every element in both arrays. I'm using letter weights length instead of postage cost length for no reason. You could use either one of them since they're both the same number. And then each time through, I'm going to show that the element in letter weights is related to the element in postage costs. So this will just give me an output that shows the cost of these guys. So weight of 1 has a cost of 49, so on and so forth. Make sense? Okay. Now this would actually be an example of where a for each loop would not be helpful because I actually do need access to the I here. Now I'm going to show you an alternate thing. So system.out.printf. And I'm going to say this letter has a weight of %f and a postage cost of %D. And then we'll say letter weights at bucket I, postage costs at bucket I. Comment out those. Let me run this real quick and make sure it's good, and then I'll tell you how it works. Oh, I need to put a little carriage return here at the end.
I want to keep that letter things to the next one.
I think it'll let me do that. All right, so same outputs here as we had before. Notice, though, I didn't have to do all the crazy concatenation stuff. So this is something that's actually left over from the printf function from C programming language, where I can give it a formatted string. So %f here is a placeholder for a floating point number, any kind of floating point number, including doubles. %d is a placeholder for a decimal number. %I will likely work as well. That was something that was added later on in C. Oh, no, it's a traditionalist. I like that. So %d is a placeholder for a decimal. So like an integer. %s is a placeholder for a string. %p is a placeholder for a pointer. I don't know how Java will treat those. We can just try it real quick.
What does printf do?
I just explained that while you were gone.
Sorry, could you review again?
Yep. Actually, I said that once you were back. So printf is another print function, okay, that allows us to print stuff to the screen. It allows us to do it in a formatted way. So rather than, if you look up here, this letter has a weight of, and then I concatenate it on letter weights, and then I concatenate it on another string, and then I concatenate it on postage costs. Rather than having to build these big, long concatenation strings, you can build this formatted string here where you put little placeholders in here. So like this guy is going to get replaced with a floating point value. What floating point value? The first parameter I gave it here. Similarly, this guy, which I did have as a %d for a decimal value, will get replaced with the decimal value associated with that. Now, if I change this to a %p, and then I just say postage costs, I'm %p in the C language is a pointer, so this should be a way of me putting in the address. I don't know if Java's going to like this. Yeah, doesn't like it. Because Java officially doesn't have a pointer type. All right, even though we've seen memory addresses all over the place. All right, so there's our formatted string. Go ahead.
Are you able to do like the same type? So could you do a float and then another float, or would that float find the first value?
Like that?
Yeah.
You can do that, but you'd have to have a separate, another float.
Okay.
Yeah, so the first one here, the first placeholder, will look for the first parameter here.
So it's for the first parameter, not the first float.
Correct. It's the parameter order. Yeah. Okay. So you actually probably won't find this very commonly among Java programmers. And this kind of goes back to when I first taught you programming. I teach it from the perspective that the language doesn't matter. Most Java programmers today started with Java. Okay, they didn't start with older languages like C and C++. So they're not already used to using printf. All right, so you probably won't see this very often, but as you can see here, it actually can be kind of beneficial, right? You know, makes life a little bit easier. So now you know a little trick where you don't have to do crazy concatenation stuff if you didn't want to. If you're only concatenating on one thing, maybe it's worth doing the concatenation, but if you start having to have strings of pluses all over the place, maybe you want to go to a printf. Notice, though, that printf did not automatically have a carriage return, so I had to do that little \n in here to kick it down to the next line. That's new line, \n. All right, questions about that? All right, so parallel arrays are kind of our, or multiple arrays as your book calls it, are kind of our gateway drug, if you will, to needing objects, to wanting objects. So back before we had C++ and we couldn't define our own objects, if you wanted to kind of represent this idea of, I don't know, letters, you maybe would have a letter struct, and that letter struct would have two parameters associated with it, a letter weights and a postage costs or something like that. Or actually, you would probably have a post office struct that had these numbers in it for looking stuff up. And then you'd have a letter struct that would hold the weight and the cost of a single letter. And I'm going to kind of show you our version of that here. All right, so we're going to go back in time and say, okay, well, I'm creating a little post office program here, and this is kind of my stuff, but I want to have I want this to be stored, I don't know, kind of in a better way or a more encapsulated way where a lot of the details are hidden from us. This goes back to that idea of, the procedural telephone, the big pile of wires where we see everything. So what we're looking at right here is pile of wires, as opposed to the object-oriented telephone where it looks like a phone and everything's hidden inside of it. So I'm going to go ahead and I'm going to create a couple of new objects here. So I'm going to create an object for a letter. So new class, and we'll call this guy letter. All right, and we're going to decide that letters have two parameters associated with them, or two fields associated with them. So they're going to have a postage cost, and they're going to have a weight. All right. Now, realistically, a letter has a weight associated with it only, correct? And then it might have a postage cost if we go to mail it. If you're at home and you just have a letter sitting there, there's no postage cost associated with it. Okay, not until you actually add postage to it. And sometimes you just guess, right? You just say, oh, this doesn't weigh too much. You throw one stamp on it. Or if you're my wife, you think something weighs 50 pounds, you just put your whole roll of stamps on it when you only needed 3. More than one time. More than one time. All right, so we're going to give 2 fields to our letters. We're going to say our letter is going to have a private, and we're going to have a weight. So we're going to say private double weight. And then we're going to also go ahead and have a private field for cost that only gets set by the post office, let's say. We'll kind of see so we're kind of solving a real life problem in an object oriented way here. So we'll say private double cost, postage cost, however you want to think of it. Let's just think postage. All right, so we have a weight and we have a postage. And when we build a letter, we're just going to go ahead and take in the weight for the letter. And then we'll calculate postage. So this guy will take in a double weight. And just as a reminder here, what's wrong with this? What's going to be the problem with writing it that way?
The name equals the drive.
So when I say weight equals weight, what I really mean is I want this weight to be equal to the weight that was passed in here. This goes back to what we were talking about earlier with parameters coming in. Okay, so earlier, bad programmers maybe would have changed that to a W, and then they would have said weight is equal to W.
Yeah, but
Because now we can differentiate, right?
there's no value.
Well, somebody's going to pass this in. Yeah, somebody's going to pass in a parameter for this guy. Okay. But now, since this variable name has a different variable name than this guy, I can say weight is equal to W, and it knows I'm talking about this weight, and it knows I'm talking about this W. But if I name these guys the same, which makes good sense because I'm taking in the weight of this letter. Why should I have to shorten my variable name just to avoid learning how programming works? All right, so what I want to do is I want to set the weight up here to the weight that was passed in. But remember, variables resolve to their most local definition. So when I say weight right here, I'm referring to that weight. When I say weight right here, I'm referring to this weight as well, because this is the most local copy of weight is the one that was defined right here. So if I want to reference the guy up here, I would say this dot weight is equal to weight. So weight right here will resolve to its most local definition, which is the one that was passed in here. This dot weight says go to the weight that's owned by this instance of the object. There's probably some joke that fell flat. I bet you this next slide says laugh. Doesn't he do that? Doesn't Dr. Locklear have laugh slides that tell you to laugh? Or does he tell you to laugh in class?
I think he just says their next exam will be really hard.
See, he's just not naturally hilarious like me is the problem. Right?
Yeah.
Once you word it right there.
Oh, your next exam will be impossible. All right. So again, this is a parameter passing thing. So anytime we ever see open and closing parentheses like this with stuff inside of it, those are parameters that we expect. So when somebody calls upon this constructor, which we'll see an example of here in a few minutes, when somebody calls upon that constructor, he better pass us a double. And we're purposely calling this guy weight because that's the kind of double we want them to pass us. The double associated with the weight of this letter. Okay? So we'll go ahead and just set the weight here for right now. And I'm going to leave this alone for right now. I'm going to kind of let it grow organically as we need it. All right. So now what I'm going to do is I'm going to go into our driver here. And let's create a bunch of letters with some weights. Now, I'm going to make this guy a little bit more generic than what we have right now. So we have weights between 1 and 13, and some of them have like a 0.5 step and stuff like that. Well, if we think about the actual post office, you know, anything up to a 1.0 would have a cost of 49 by this example, right? But anything that's heavier than 1.0 but lighter than 2.0 would have a cost of 70, right? Okay, so we don't have these like strict, well, it either weighs 1 or it weighs 2 or it weighs 3. There's an actual weight associated with it. So what we're going to go ahead and do is we're going to fill up an array of letters with weights that range between 1 and 13. Okay? And then we'll create random numbers between 1 and 13 and look at that. So we'll go ahead and we're going to say we're going to create a array. And remember, creating an array is type followed by open and closing square brackets followed by the name. So we'll call this guy the letters. And this guy is going to be equal new type and then size. So we'll create 100 letters, let's say. All right, so then we have to decide what should our type be? Well, we want to create an array of letters. An array of letters. So that's an object we just created. We just brought a letter object into existence and we wrote it. Now we're creating an array to hold those kinds of objects. That make sense? All right, so now I need to go ahead and I need to fill, I'll just go ahead and dump this because we'll go and read it from the other thing. Well, we'll have a printf example in our other one, but we'll do this for V. Okay, so now I can get all this. All right, so I have an array of letters, and I want to go ahead and fill my array of letters up with letters of random weights. Okay, and I'll go ahead and write a little side function for this, just to keep practicing writing functions, right? So this guy is going to be, actually I can, well, I'll make him static. I will make him, we're going to call this guy fill letters. He's going to take in a letter array here, and I'm going to call it the letters. But as we've already learned today, it doesn't need to be named the same as what is named up here, right? Because this guy is just, this function takes in a letter array. And whatever I call it here is how I have to use it inside of here. And this guy is just a synonym with this guy up here because their memory addresses match, not because their names match. Okay? So fill letters will take in a array of letters, and we'll go ahead and we're going to create an instance of the random class. So random r is equal to new random. And this guy is going to require that I import java.util.random. So notice it has little red squigglies underneath it. If I hover over that, it'll say import java.util.random. Okay. He's being sarcastic. He's never seen the red squigglies. You've seen thousands of red squigglies. Okay. Or he hasn't seen not red squigglies. One of the two.
Depends on the printed return.
What kind of variable is letter? Because
Oh.
it's like red.
Watch 60.
Oh, because I haven't put my return type in here. I'm not going to return anything. I didn't put my return type in for my function. So this is a function called fill letters that returns nothing and takes a letter array as a parameter. Syntax for a function, right? So now I'm going to create an instance. Good.
Wait, what did you do with random?
Oh, before I imported anything here up top, it was upset with me. So if you just hover over it, it tells you one way to fix this is to import java.util. Just click that. The other thing you could have done is just written it yourself up here, import java.util.random. All right, so now I have access because random lives in a different library. We just gave ourselves access to it because Java is a really big thing, and java.lang used to be the core Java language, and didn't we say now it's java.base.lang? I think that's what it is now. Yeah, I think we looked at the documentation. It was in a little bit different place. Yeah, that is called java.base.lang. Doesn't matter. Just random is something that lives outside of that. So we had to give ourselves access to it. And we did that through this line here. All right, so now the random class has a whole bunch of instance methods in it. And let's actually jump into the documentation here. So I go to java.sun.com, and one day I'll probably memorize the new thing, Java SE, then Java APIs, then just pick one of them. Yeah, it's java.base.lang is the, so I'm going to go to java.util. Where's java.util? It's not inside a base, is it? It is. So there's java.util. And inside of here, we have a class called random. Here's the random class. And now we can look at the things that random can give us. So I have something called next double. So this returns the next pseudorandom uniformly distributed double value between 0 and 1 from the random number generator's sequence. So I need to multiply this by some value to give me the right range, right? So if I want a value between 0 and 13, I can multiply whatever this guy comes out with by 13. So if it's close to a 1, like 0.99, this will give me a 12 point something, right? If it's close to a 0, that'll give me a point something, less than 1. So I can generate a whole bunch of random doubles, and it should give me values that are in the kind of the right size-ish. So we'll go ahead and we'll go through every element of the letters. And I need to first fill the letters up with actual letters. So I'll say for int I is equal to 0, I is less than the letters dot length. That's the size of that letter array that currently doesn't have actually any letters in it. It's just a box built for holding a bunch of letters. Then I plus plus. And then I'll go ahead and say the letters at bucket I is going to be equal to a new letter. So I'm creating a brand new letter. So the new keywords are real estate agent that returns a memory address. Letter is our constructor. What does our constructor take? It takes a double as a parameter. And we've decided that our the weights of our letters in our example is going to be between a 0 and a 13. Right? Okay. So we're going to pass it r dot next double, which will give me some value between 0 and 1. And I'll multiply that by 13. So that should give me a value that lives somewhere in the range that is greater than, well, doesn't necessarily have to be greater than 0, because technically you could randomly generate a 0.0. And then you'll have an incredibly light letter. We're going to allow for that in our example here, all the way up to a maximum letter weight of 13 in the event that we randomly generate a 1.0. Make sense? All right, so this creates a brand new letter object using this constructor. How heavy is the letter? It's this number. Some random double between 0 and 1 multiplied by 13. That should give it a weight, a random weight in that range. All right, and I'll store that letter in bucket I of the letters. Okay, now, if I go through, and we're going to go ahead and call this as a class method or an instance method. How do you know? Static, how do you call class methods? Name of the class in which the method was defined. So there's fill letters. We'll pass it the letters. Okay. And then I'll go ahead and I'll write a print letters. And we'll do this as a for each loop just for practice. So for letter L in the letters, we'll say system.out.println. This is a class method or instance method? Class method. How do you know? Static. How do you call class methods? Driver.print letters, the letters. Okay. What will the output of this program be? Make sure you always resolve variables. If I were to give you this code on a test and say, what will the output of this program be? What will I see on the screen? What would you say? What's this going to print? What's L? What's L? I've highlighted the word that you should just say as the answer. It's a letter. The L is a letter. Okay, letters are objects. If I print out an object directly, what will print out? Memory address. So it's going to print out memory addresses for a whole bunch of letters. Okay? Because that's what the new keyword did. New keyword goes and gets me some memory. That's what I did down here. I said, create me a letter. So a new letter, this particular letter. Make sense? So if I were to go through and actually print these guys' weights out specifically, I can say L dot, for instance, maybe get. Let's just finish up with that real quick. Just for the moment, I'm going to make that not private, just so we can see it real quick since we're out of time. So now I'll print out L dot weight, and now we'll see a bunch of doubles. So do those look like they're in the range of 0 to 13? Yeah. So we have a 9-point stuff, 10-point stuff, 5-point stuff, 2-point stuff, 0.84, blah, blah, blah. So we have some random weights. So when we come back on Tuesday, we'll kind of finish this up. No homework over break. Remember, we'll also talk about the exam on Tuesday. Sound good? Questions, comments, concerns, bribes? Remember, today's student, faculty, staff Bible study. God and grub. Go to the cafeteria, sign in, get a free lunch, get your tray, take it down to the terrace room. It's from noon until 1. I will see you all there, and I'll save you a seat.